Today we'll discuss about the cell design during our talk about the cellular communications. And the end, we'll discuss how to improve the capacity so that your call is not dropped. So let us go one by one. What is cell? We are talking about cellular communication. What is cell? This is a very important question. सेल का नाम आपने सुना है, सेल सभी जगह होती है, हमारी ह्यूमन बॉडी में भी सेल है, लेकिन जो सेलुलर कम्युनिकेशन में सेल यूज होनी है वो ह्यूमन बॉडी में नहीं है. सो आवर मेन एम्फेसिस इज ऑन cell, that is to be used for wireless and mobile communication. Basically, if you define what is cell, the definition of cell is an enclosed area which has its independent working is called cell. Whether cell is a human being, whether cell is a cellular communication, or cell of the creature inside the sea, or any other things, but cell is cell. In wireless and mobile communication, you have seen lot of towers in your city, and these towers are called the transmission tower. Sometimes we say BTS. I wrote mobile is the mobile stations. You have gone through so much about the cellular communication, but who has given the idea about cellular communication? This is that tower that is available in all part of the cities. And if you see this tower, these are the antennas. But these antennas are not same as that of this one. Discuss later on. For your wireless and mobile communication, these are the antennas. And this antenna is for their internal use, to be used by service provider for sending their data. So I was talking that who has given the idea of cellular communication or cell design. This idea has been taken from honeybees. See, this is one of the honeybee hive. And these are the creature. ना तो इन्होंने ITI की है, न डिग्री की है, न PhD की है, और न मेरे जैसा यूनेस्को फेलो जापान जर्मनी में रहे हैं, लेकिन देखिए कितनी नाइसली जो है अपनी सेल को बनाया है. Each hole represents a cell. Even you cannot make all these identical cells if you do not have the instruments. The small creature never use these instruments, but they have designed. And their leader is the queen is here. Under her direction, they have developed a large colony and purely hexagonal in nature. Unless the angle is 120 degree, you cannot make a hexagonal. But they have created not only the angle, but all the cells are of equal size. So the honeybees, they have given some idea, or we have taken some idea to develop our cellular communications. Cell that were hexagonal in nature, but we have nowhere we defined what should be the shape of cell. Cell may be circle, square, triangle, or any type. I will like to add one more things. We have discussed here circle. This is a circle. Another is square. This is the square. Third is triangle. Triangle. And fourth is ETC. What are the ETC? We like to see here. This is a cell. This is also cell. This is also cell. This is also cell. But whether they are useful for our wireless mobile communication, it means all the cells which are going to be used for mobile communication, they should follow some geometry, and that is called cell geometry. Means they can be repeated in any direction under certain angle. But these types of enclosed area, though they are cell, but they don't have any geometry. So they cannot be defined as a cell for wireless and mobile communication. Though they are cell, our emphasis will be mainly on the circle, square, triangle, and if anything is available, we'll discuss. So these are various shapes. One circle, this is an actual cell. I will discuss what is actual cell. Hexagonal, rectangle, triangle. 1, 2, 3 and 4, they are clear to you. But what is by actual cell? Actually, this is the basic deformed shape of this circle is called the actual cell. This you have done by making the instruments on your paper. But this is the area you have taken on actual on the site, making the signal strength equal in the all part of the boundary. So that may not be exactly circle, but of this shape. If you take this one also, this is also not going to be completely or perfect hexagonal. This will also changed. All these will be changed if you take the actual reading at the site. And boundary of the cell means the contour has equal signal strength. So I told you they should follow some geometry also. They should be attached with each other. If they cannot attach each other, they cannot make any correlation with each other. This cell cannot be used for our cellular communications. So these are various shapes of a cell, and we have defined what is the actual cell. Cell means they should have some correlation with each other, and they make a perfect adjustment with boundaries. If they don't have boundaries and they cannot make a terrestrial communication with each other, they cannot be defined as a cell for mobile communication. We have gone through the radio and TV transmission. So far we have not defined. We have only seen that it should be hexagonal, but we have not proved it. Let us first study how the radiation takes place. See here in this figure, this is your transmitting antenna, TX. In case of radio, you get the various contours all around the distance. If the distance increases, the signal strength decreases. But the contour takes the same signal strength at each and every part. So we have not defined what is difference between the wireless and mobile communication, and difference between the radio transmission we have not discussed, but they are not same. In case of radio and TV transmission, you try to cover the maximum signal strength or maximum area, means transmitting power in your hand, you can increase and decrease. But the first condition in case of mobile, signal within cell. First condition, your signal is not supposed to go outside the boundary of the cell. And this was not the condition in case of the radio and TV. If you increase the signal strength, your may cover larger area. If you decrease, lesser area. But the first condition in wireless and mobile communication, your signal is not supposed to go outside the cell. So this is the first condition that was not in radio and TV. And what is the second condition? Equal signal within cell. Equal signal level in whole of the cell. And you are electronic engineer. There is no theory or no such circuit that can maintain equal signal level all over the cell. If anybody has seen this thing or has studied, please tell us. If you go away from the transmitter, your signal strength will decrease. Then you will say, how you maintain the equal signal level? Why you have put such condition? That is possible by some other control signals, control channels. Control channels. Whatever audio you get, that is called the traffic channel. And how signal level is maintained, that is by control channels. We will discuss, that is called the power control. Name is power control. And we'll discuss this thing in some other forum. At present, we'll discuss about the cell design. So this was about the contours in a transmission. Let us see here some figure. These are two conductors of any electric wire, and in between the two conductors certainly there is a electromagnetic field, means especially the electric field. But if you keep away the two arms of a cell, this becomes electric field. If we still decrease the distance, this behave like a dipole, and that is called the antenna. So what is the size of antenna and the shape of antenna, that will depend upon the frequency. So whatever area is covered by single transmission tower under any base station, and that is called the cell area. So area covered by a single transmitter in a cell, that is called the cell area. In our radio and TV, transmission power is not defined. We define the location, how much area you want to cover. Accordingly, transmitting power is increased and decreased. But there is an international rule that the transmitter, whether the TV or it is the radio, of same frequency cannot exist so much kilometer. This is the international rule. आप उतने डिस्टेंस से नीचे दूसरा ट्रांसमीटर उस फ्रीक्वेंसी का नहीं लगा सकते हैं. लेकिन मोबाइल कम्युनिकेशन में ऐसा कोई रूल नहीं बना है। एक ही जगह 6 सर्विस प्रोवाइडर सेम फ्रीक्वेंसी रिले करेंगे। अंडरस्टैंड? तो बेसिक डिफरेंस ये है कि रेडियो एंड टीवी में तो हाई पावर ट्रांसमीटर्स आर यूज्ड, 1 kV, 2 kV, 3 kV, and 100 kV, kilowatts. I'm talking about kV means kilowatts. But you knew what is the power of your mobile tower? 8 watt. Power of your mobile set is 2 watt. So they will not able to generate the high signal strength. So you use very low power transmitters to cover a small area in case of the mobile communication. We do not use the transmitter of very high power. Please come on this side. It becomes easier for me to communicate. So in case of mobile communication, you use LPT, low power transmitters. But in case of radio and TV, use high power transmitter. For same audio, the transmission technique is changed. Audio is same, voice is your. But in case mobile communication, in case of radio communication, means transmission technology is not same, totally different. So let us see one by one whether you can use the circle or square or equilateral triangle or hexagonal for mobile communication. In the very beginning, I explained the honeybees and they made their hexagonal cell. Why they made hexagonal cell? Why they cannot make the circle, square, triangle, other things? It is also possible. But let us go through and see our reasonings. Why we have not used these things? So performance of a cell depends upon shape, size, and material available inside the cell. What is the problem with circular cell? Why you have not used the circular cell? Let us see here. Suppose these are the cells. Each cell has its own transmitter, transmitting tower. At the center, this is TX1. This is TX2 center. This is TX3 and this is TX4. You know that your signal should not go outside the boundary of the cell. Means signal should remain within this boundary. Because this was the condition for mobile communication. Now who will provide the signal to this place? Is there any way? Tell us. यहाँ सिग्नल कहाँ से मिलेगा? कोई रास्ता है? There is no way to provide the signal at this place. Therefore, circular cell is not suitable for mobile communication. Let us see some other cell. And this was the gap. Because of the gap, we cannot use the circular cell. Let us take some other cell. What is the other cell? Rectangle. I'm sorry, drawing is not correct. So these are 4 rectangles. At the center of this is the TX1. At the center of this one is TX2. At the center of this is TX3 and center of this TX4. How it cover? You have not defined the area. Whether you want to cover the internal boundary or you want to cover the external boundary. First tell me. Whether you want to cover the internal boundary, let us see here. We are covering the internal boundary. Problem is solved. Problem is still same. There is no solution. In the same place. You have used the internal boundary, same as in case of surplus. Now use the external boundary. That area has gone. But this is overlapping here. You will not be able to decide whether the signal belongs to TX4 or TX3 or any other place. So rectangle cell is also not suitable for mobile communication. Whether you use internal boundary or you use external boundary, problem exists. In case of internal boundaries, gap is created. In case of external boundary, overlapping takes place. So rectangular cell is also not suitable for mobile communication. Let us try to triangular. Make the triangle. See. This is one triangle. And that is equilateral triangle. Equilateral means all the sides are equal. Angle is 60 degrees. This is the definition of equilateral triangle. Now the same situation arises here. Use the transmitter at the center. Use internal boundary or use external boundary. Problem is not going. So single triangle also not suitable for mobile communication. Same problem as the gap or overlap. Now let us try some more triangles. Instead of one triangle, instead of making one, I will make 6 triangles. One, 2, 3, 4, 5, and 6. Instead of taking one triangle, we have taken 6 triangles. 6 equilateral triangle makes a hexagonal. So this shape is called the hexagonal. And the number given 1, 2, 3, 4, 5, 6. They are called sectors. When I will talk about the cell coverage, then these are called the sectors. Now let us see here. Put this transmitter at the center. This is your transmitter. Cover the internal boundary. Still some gap. Cover the external boundary. Still gap. But the gap is less compared to either circle or triangle. The usable area is more here in case of the hexagonal. If you compare this circle, internal and outer external circles, no doubt the area of hexagonal is less compared to the external circle, means circle, but difference is very. This may be one region only, but this is not the confirmed region to use as a hexagonal cell for mobile communication. This is one region because the usable area is more. Let us, there may be some other regions. So 1, 2, 3, 4, 5, 6, these are called the sectors. If you see this figure, 1 and 4, 2 and 5, 3 and 6, they are of the same color. I would have put 1, 2, 3 of the same color and 3, 4, 5 the same color, but there is some region. I put the purposely the 1, 4, 2, 5 and 3 share of the same color. Instead, I give this answer. In the end of the lecture, yours will reply, means realize that why you have put the same color. You will realize at the end of the lecture. Instead of telling me, you will realize it. If you do not realize, I will tell. See at this figure. How many triangles? So many triangles. You start from this side, 1, 2, 3, 4, 5, 6, 7, and so many. And out of these triangle, take any 6, they make the hexagonal. Take, whatever you like, they make the hexagonal. So this is called the multi-triangle makes cluster. Cluster means they are attached with each other. And you cannot distinguish whether you are talking about this triangle or this triangle or this triangle. They have equal shape and size in nature. They are part of the cluster. And these six triangles makes the hexagonal cell. And they can be easily stacked, and now tiles are also available. Hexagonal cell tiles are available in the market. Either used in the floor or in the wall or where you like. Now see this figure. This is one of the BTS tower. 1, 2, 3, 4, 5 and 6. 6 dipoles. And there were 6 sectors. We can say that these 6 dipoles has some relation with the 6 sectors. Let's see what are the relation. Here 1, 2, 3, 4, 5, these are sectors. 1, 2, 3, 4, 5, 6, these are the dipoles. It is quite possible that number 1 is attached with number 1 dipole, number 2 is attached with number 2 dipole, and number 3 and so on. Each dipole is for each sector. This gives some idea. The hexagonal and their coverage, some idea. You have seen this building? You have not seen? In the evening, go outside and see. My aim is not to show you the building. My aim is this area. It had the trees, big buildings, surface, grass, and backs out clouds and other side the lake also. My purpose is to say the signal strength cannot remain same everywhere. it will be hindered by either trees, buildings, grass and other things. So that is the purpose, to show you the building. And the very first, if you remember, I show you the circle and then actual circle, and this is the region, the circle that you made by your meter or your scales, and this is the circle that made by equal single contours. So signal will not remain same everywhere, so your cell will differ. Why use the hexagonal cell? Now this comes question. This was only idea I gave, that usual area is more compared to the circle, but that is not the confirmed information. Why use the hexagonal cell? Now all of you, the electrical engineer, in case of radio, what is the range of radio? (30 megahertz). Medium wave, maximum 30 megahertz, then short wave and other things. If you go FM, that is line of sight communication. So at 900 megahertz, the radiation pattern of antenna will remain circular in nature, as in case of the audio, that was maximum 30 megahertz. All of you engineer, no such antenna is available, not so anybody has designed such antenna whose radiation pattern is circle in nature at 900 megahertz bands. They are all directional. Direction means figure of 8. So none of the antenna has the radiation pattern circular nature at 900 megahertz. So transmission is not the circular in nature, it is directional. To cover a hexagonal or to design a hexagonal cell, that is another reason that why the cell has, means circular cell has not taken, why you have taken the hexagonal. So now we'll discuss about why you have taken the hexagonal. See, these are the cells, this is the area, this is the perimeter. Square, not useful for transmission, we have already defined. Area is R square, perimeter 4R. Triangle also not suitable because of the either take internal or external because of the gap. Now our comparison is between the circle and hexagonal. Circle was used for the radio and TV, means radio transmission. TV not basically a circular, but is different type of transmission. We have used 4 dipoles or 2 cross dipoles, and circle was only for radio communication. So our comparison is here between the hexagonal and the circular. Area, 6 times of the triangle. Under root 3 by 4 R square was the area of triangle. If you multiply by 6, it becomes the area of hexagonal, and that is 3 by 2 under root 3 R square, and perimeter is 6R. In case of circle, it is pi R square or 3.14 R square, and this is 2 pi R. Now see, the perimeter of circle is more compared to the hexagonal. If you calculate this one, the means the area of circle is more compared to the hexagonal, but the difference means the ratio is less in case of the area, very less difference. Though it is more compared to circle, the area is more, perimeter also more, but the difference is very, very low. Whether you use circle or use hexagonal, the difference is very low. So this may be the another reason why use the hexagonal cell, and that is also not a confirmation for the hexagonal cell use. So cell coverage, another problem, that at 900 megahertz, no radiation pattern is available for any antenna that has this circular in nature. So that is all indirective. So this may be the another area or another region to use the hexagonal cell. And a dipole, what is the wave shape radiation pattern of a dipole? See here. This is one dipole. And what is the radiation pattern? This is the radiation pattern. This is about the, I am talking about X in Y direction. And this is the feed dipole. If you have put the dipole on vertical, so X direction, these are the radiation pattern. The radiation pattern defines the quality of antenna. It is not same for all. Radiation pattern. No doubt it is directional, but this angle will not remain same in all antennas. It will vary from antenna to antenna. And varying parameter may be the metal used, the difference between the feed points, displacement of the feed points. This is XY direction only 2 dimension. But if you see in 3 dimension, displacement point may change. And I published this paper in 1974. What is the radiation resistance? It changes according to the displaced feed points. Go on decreasing. If you go on increasing the displaced feed points, either X direction or in Z direction or in Y direction. That paper I published in 1974. So this is figure of 8. Now see this figure here again. This is lambda by 4 above this surface area, and this is lambda by 2. In general, the dipole is lambda by 2, half the wavelength. But why it is lambda by 4 here? In case of radio transmission, the frequency is very low. If we calculate the wavelength and the dipole length, the antenna becomes in kilometers, and very difficult to make a dipole of kilometer. So earth is taken as a reflector, so half has been shown below this one. So in case of radio transmission, the earth is taken as a reflector, so only quarter wavelength antenna is installed. But if you go on increasing the frequency, the size of dipole go on decreasing. When you go up to TV, means up to 65 megahertz or say 62, 67 megahertz or 61 to 67 megahertz, it is around 1.5 meter. If you go band 3, 100 is about to 230 megahertz, it comes less than half meter. So go on changing the, increasing the frequency, dipole side is going to decrease according to the frequency. First of all, this is XY plane, and this is my mistake that I have put here Z. So it is X. And this is the dipole. So wave shape is of this type. So please correct it. It is XY plane, not the ZY plane. That was figure done by computer. This is a figure done by the actual data taken from radiation pattern measurement equipment. This is the dipole and this is the wave shape. And if you rotate 3 dimensions, it looks like a tire. If you rotate 3 dimensions, it looks like a tire. It means at this place, you will not get the signal if you look in 3 dimensions. In a tire, in 2 dimensions you are getting the means the signal, but 3rd dimension there is no signal. This shows that one dipole is not enough to cover the gap area. You have to provide more than one dipole. And this is the measurement facility, how the actual radiation pattern is measured. See this figure. This is correct figure in XY plane. This is the radiation pattern of any dipole. But nowhere we have defined what is this angle. What is your requirement for any hexagonal cell? What should be this angle? 60 degree. But nowhere it is mentioned is 60 degree. If you take any dipole, you cannot get exact 60 degree radiation pattern. Can you increase the angle or you can decrease the angle? The two things. Tell us. Angle is very low here compared to that figure. Or you say here, this figure, this is the radiation pattern. See, 1, 2, 3, 4, 5. This is almost same, but different radiation pattern. Basically, what is doing? The angle is changing. This angle is changing, and you are getting different waves. Here, question is one thing: your requirement is 60 degree, and you do not know what is the angle of this radiation pattern. Can you change the angle? Please tell me. Tell me. Possible to change. How will change? Have you Yagi antenna? Name of Yagi antenna? Have you heard the name of Yagi antenna? What is it that antenna was used in TV reception long back? Actually, we are changing the angle. If you take this as a base, if you go on putting the directors, what you are doing? You are changing the angles, reducing the angles. Angle is continuously going changed. It means it is possible to reduce the radiation angle. It is possible to increase also. Rare chances. Very rare chances to increase the angle. In general, the angle of any dipole is more than 60 degree. You can decrease. It is almost say sometimes 90 or sometimes 70, 80. But difficult to increase it. By using some more elements, you make a different device that you can increase the angle radiation pattern, but you cannot exactly say that I have increased the radiation pattern. You have increased the coverage only, not radiation pattern. So by adding these elements, these are called the arrays, antenna arrays. You can change the angle. You can change the angle, it means you can bring it exactly to 60 degree. If you can bring this 60 degree, it means you'll be able to cover your sector. There are 6 sectors. an hexagonal cell, and you have to cover it. Let us see how we cover it. So the cell area, covered by a single tower, that is called the cell area. But in tower, there not one single dipole. There may be, you get 3, somewhere 6, 7, 12, 15, 20. You say, my teacher had taught me only to put only 3 dipoles. But how it became 6? How it became 9, 12, 13, 14? Why would this so? We'll discuss this thing. Unless I reply this thing, do not leave me to leave this place. So this is the pattern that made by graphic artist, not by me. I will make it. May not be the same, but how the coverage is done. I will make bigger figure so that you can see it easily. See, 1, 2, 3, 4, 5, 6. I say A, B, C, D, E, and F. Connect any 2 lines that are passing through the hexagonal. Take, that is called the dipole. Take any 2 lines that is passing through the cell. Take any name. I will make that dipole. Suppose I take this A and D. Understand? This is the dipole. And the figure of 8, you have covered. Suppose take B and E. This is that area you can cover. And if you take this F and C, you can cover this area. This figure is almost same as shown in PPT. But that was made by the graphic artist, and this is made by a teacher who is not a perfect graphic artist. By chance, the person who made these figures was sitting back side. He prepared, he is not here. All these, but there are, because all these lectures has been recorded. So that was made by graphic artist. So now you get some idea. But if we need 3 dipole, we have put the 6 here. This is one question. I will say, still next figure, you have to cover 360 degree area you have to cover. Oh, that figure is not here. I will take only this one. Now the question is, if you can cover the whole hexagonal by 3 dipole, why there are 6 here? This is a question to be put. जब आपका 3 में काम चल सकता है तो 6 क्यों लगाए? और 3 भी लगे हुए मिलेंगे आपको मार्केट में. The tower, which has only 3 dipole, that is a BSNL only. The other service provider, they put 6. Why they put 6? If you put the dipole, whatever behavior is between 1 and 4, 2 and 5, 3 and 6 will be equal on both sides. Either will change, it will also change accordingly. But I have shown the figure of Nitar Chandigarh. Somewhere tree, somewhere buildings, other things. You do not expect the same signal strength at same place on both sides. it will be changed. If changed, it means number 2 needs the different antenna and number counterpart 5 need different antenna. Not only dipole, different antenna. Maybe with array, because you have to cover required area, and required area according to actually area is not same as calculated on the blackboard. It differ. I will discuss later on these things. So service provider in the private sector, that they have the quality of transmission, and they put one dipole for each sector. In this sector, 6 dipole. So this is that figure. I will show another figure and then reply why more than 4. You have gone through that figure. Where that figure? I am unable to search that figure. Anyhow, I showed you the very first figure, in which antenna means dipole or not the generator. We are use the Yagi antennas. Understand? If you remember, in the beginning of the lecture, I shown tower, and the antenna were not same as this one. Not the similar nature as this one. They were means the Yagi antenna. What is the reason? Using the dipole, no doubt you will be able to cover in better way this area only. What will happen to these things area? See here, this area. Dipole will provide only a particular wave shape, and to cover that area, this area, you have to use more arrays that can change this shape, the whole things. So you need not to put only the exact dipole, but multiple arrays to cover the low line area. So that is the region. Then another region is, sometimes you see 6, 15, 20, 30, 40 antennas. Not 40, up to 24 is enough. This service provider share the cost structure, because the structure takes some cost and they share. In sharing, say these are your 6 antenna, these are 6 antenna, these are 6 antenna, so 18, 24 antenna they can put. Now the question is, in 900 megahertz band, I will talk later on the improvement. What is the 890 to 915 megahertz? This is down channel, and spectrum is 25 megahertz. This is the difference. This is called the spectrum. And cost of the spectrum, you know, have you imagined? So many thousand lakhs of rupees. और इसके पीछे कुछ लोग अंदर भी हैं. That was the spectrum. Very high cost. Only big service providers, they can buy complete 25 megahertz spectrum. The small service providers, those who combine each other to share the tower, they do not have full 25 megahertz spectrum. Some have 5 megahertz, some have 10 megahertz, some have 4 megahertz, some have 3 megahertz. Understand? And another thing, in case of mobile communication, 25 megahertz the spectrum, and channel is only 200 kilohertz. 200 kilohertz means 25 into 0.2 is equal to 125 channels. If everybody will have the same channels, they will not able to share. Understand? They will disturb each other. So what they do? The service provider, Suppose he has 5 megahertz, another has another 5 megahertz. They do not match, overlap each other. Then they make the common spectrum and common tower, and they share each one. If everybody has 25 megahertz spectrum, like Reliance, BSNL, and Tata, they do not share because they don't have any spare channel. So sharing is possible only the service provider which have the limited spectrum. And if any channel is common, they rotate the antenna. They do not keep the same thing. So radiation pattern is rotated. So signal is saying the variation. You know, if you go away from the transmitter, signal strength decreases. If you plot a curve between the power means transmitting power, and the distance, the signal strength decreases. Go away from the transmitter, signal strength 1. You have complete, I told you, a cell. So far I have not defined the size of the cell. But I have told that should be equal signal level within the cell. And that is not possible to maintain by electronics. Instead I forget what is the size of the cell. You have gone through. What is the minimum size of the cell? What is the maximum size of the cell? Minimum and maximum. Minimum is 0.5 kilometer and maximum is 37.5 kilometer, and generally we say 35 kilometer. I will talk about the how to improve the coverage, improve the area to discuss these things. But I will tell only here the 0.05 kilometer that is available in Chandni Chowk, Delhi, very congested area. And in case of the 35 kilometer that is available in Jaisalmer. I want to say here the subscribers quantity are means the number of subscribers is not dependent on the area in case of the GSM. They are dependent on the cluster. So when we will discuss about the improvement in the coverage, we'll discuss these things. The same figures we have gone through here. This is figure about that your signal strength will go contours all around this thing. These are animations, and I cannot show the animations, but the films are available. They all are animations. So far we have talked only about the one cell. If we take the two cell, what will happen? Whatever discussion I have done here, that is based on single cell. Tx1, Tx2, cell I and cell J. R1, R2. R1 is not same as R2. They are different. Different service provider. Maybe same one, but depending upon the situation, it may differ. Now let us see the behavior. We have discussed the signal strength decreases, and it is equal signal strength contours are available. You go away, the signals will go on decreasing. See here. See here, this is one cell, this is the another cell, and these contours of the equal signal strength. And see here, this is decreasing minus 60, minus 70, minus 80, so one decreasing. And similar situation is this one. And this is the overlapping area. Now realize the situation. This is the figure you have made by your equipment or in tools. But if you go in the field, there are so many factors: the cloud, atmospheric condition, temperature, and the buildings, so many things. They will not permit you to make the perfect circular, perfect hexagonal cell. And atmospheric condition will change the situation. And factors may be reflection, presence of other particles, and there's so many things available in the atmosphere. And so they don't allow you to make the exact signal length. Say this is one case of reflection. Signal strength will go on changing. If the signal is multi-reflection, maybe get from two places the same signal. Maybe one delayed, one be direct one. It will not be exactly at same location. You will not get signal other side. Multiple reflections are available from so many places. So making all these parameters, whatever the concentric circles you made by your equipments, they will not remain same the things. They are not exactly same figure. Both have changed. Cell I and cell J both have changed. Quite possible the area of certain area of this J is entered inside this one, and that becomes the region of interference. Understand? If these conditions are same, cells are identical, we have developed our system that your signals should not go outside the boundary of the cell. But if the cell is deformed and they are very nearby, that may be created the region for the interference. I was searching that tower and see here that antennas. To optimize that area, where the signal cannot reach, use the different Aggie type of antennas. So whatever cell we have designed and whatever cell the honeybees have designed, exactly same in nature, but size is not same. Understand? This is the basic difference. Shape is same. So this was about the cell. So capacity in megahertz. See here, your spectrum is up and down channel, the spectrum is 25 megahertz. And 200 kilowatts is each channel. How many channels are available? 125. You have gone through. Suppose we take the example of not everybody has 25 megahertz spectrum, say only 10 megahertz spectrum. Understand? In 10 megahertz spectrum, how many channels? See here, 50 channels. And we know that each cell should have 7 to 8 channels only. So how many cells are required to accommodate the 50 channels? Approximately 7. The 7 cell is called the cluster. This is called the cluster, where the complete spectrum is accommodated, and the number of cells, that is called the spectrum. So now first question is here. Let us go written here. Each channel have 8 slots. channel frequency, starting from 890 to up to 915 megahertz, 200 kilowatts each channel. And each channel has the 8 slots. 1, 2, 3, 4, 5, 6, 7, and 8. Listen. You have 125 channels, and each channel has 8 slots. So 1000 people can talk at a time in cluster. Listen, I'm talking about cluster, not about the complete system. In a particular cluster, GSM, which is 10 megahertz in nature, the spectrum, 10 megahertz you have taken. So 1000 people can talk. That is the maximum. If a spectrum is going on decreasing, the number of users will also go on decreasing. This is based on 25 megahertz. Understand? For 25 megahertz spectrum, the cluster size is bigger and 1000 people can talk. If the spectrum is low, this will also less, depending upon, because the channel will be low. So now the question comes, if becomes 1001, we have taken the complete full spectrum. 1001 subscribers come in that cluster. What will happen to this subscriber? Whether I will be able to talk, I will not be able to talk. जब permitted 1000 है तो उसकी कॉल ड्रॉप हो जाए. तो रास्ता क्या है? What is solution? No service provider lose his business. We will find out some way. They calculate the C peak period. If in peak period the number of subscribers increases, they reduce the slightly voice quality. The data send half rate, so they can accommodate more number of subscribers. If it's not peak period, is permanent. The population of the area is going increasing and subscribers increasing. Then you have to find out some other way. If each cluster can accommodate only the 1000 people, you create another cluster. You will be able to increase the another 1000 people. Area you cannot increase by physical way. If Chandigarh 10 by 10 kilometers, you cannot make 100 by 100 kilometers. No way. Only way is to more smaller sectors. Understand? Similar is the case in case of the mobile communication. We split this. So what is solution? Call will be dropped. Cell splitting or cell sectoring. Let us see first cell splitting. Divide into more number of cells to increase the coverage. Cost, efficiency, other things will increase. You have to mind it. You have to mind it, because if you want to accommodate more subscribers, you have to increase the business. Certainly, cost will increase. Increase the traffic. Split cell into number of cells. See here, these were the original cells. Then make the smaller, and then the smaller go on making the multiple of the original cell. You cannot leave the base of the multiple. So this was the original larger cell. If your strength of the subscriber has gone more, come to the slightly smaller cell. Still, if the strength is increasing, go to much smaller. It's quite possible you make the still smaller than this one. Within that area, see, so many, if you have made this thing here, you can make here, you can make here, you can make here. More number of cells can be created. And so many times subscriber can be increased. This is the one idea about the GSM to increase the capacity. whether the similar things is available in GSM, means CDMA, may not be same. Let us see what they do. So you use the additional base and other things you create and increase the area. So this was about the GSM. Now what the CDMA is possible. CDMA do not make such clusters. In CDMA, only one channel. And one channel you put the different codes. So there is no question of making the such cluster. So what they do? They either split the antenna or they make the directional antenna or different thing they will do. Different type of technique they will use. So these are different types of. This is the omnidirectional, not available in case of the audio. You cannot at 900 megahertz you cannot make omnidirectional. So make the 120 degree. Cover this area using 3 dipoles. This is another way. Same thing. Either put this way or put this way. Same thing. Or make the 90 degree or make the 60 degree. So different ways of the covering the area. It means the antenna design will also play major role in case of the CDMA, and the sectoring will play major role. So you can make in the antenna placement in different way. Number of antenna will remain same. 360 degree you have to cover. Sectoring, decreasing the interference, because you have, if you change the angle sectoring, the interference will be reduced. Alternate way. So far we have been putting the transmitting tower or TS, a BTS at the center only. Is it possible to put in the corner also? Whatever discussion we have done, we have put always the transmitting tower at the center of the cell. But there is not necessary that put the transmitting tower at the center. See here. Put at the corners. See here. And it will give the same effect as putting in the center. See. Now see the capacity of the CDMA. The capacity of CDMA is affected by the processing gain of the amplifier, whatever you have put in the antenna gain and other things. Ratio of the energy per unit noise bit E by N, noise factor, signal to noise, is very important things. Voice activity factor, which type of voice you are using, frequency reuse efficiency, and number of sectors in the cell. So this is the formula, same formula. The NP. This is the capacity in terms of number of subscribers. 125 megahertz per channel. So there is only one channel in case of CDMA, and that is of 1.25 megahertz. Only one channel. And WR, ratio of the splitting code, with the voice activity factor, that is taken approximately 2, and the sector per cell generally taken 3. 120 degree means 3 sectors. And energy, minimum ratio of the energy to noise, that is 6 dB 4 you have taken. And frequency reuse factor is 3 by 2. It means these are the parameters that affect the CDMA system. In case of GSM, there was no such provision. Either yes or no. Either reduce half the data rate or split the cell. There is more provision here. Now see this formula. If you can decrease the signal to noise ratio, EBN by N, you can increase the NP. Understand? Very easily. And signal to noise ratio, if you are able to afford lower signal to noise ratio, you can accommodate more number of subscribers. And this is the policy mainly used in case of the CDMA. So it is signal to noise ratio dependent. If you take ideal, 128 calls per 121.25 megas. That was the ideal situation. But ideal situation never remains the ideal. So it go on changing. The capacity system is interference limited, while the capacity of FDI TDMA system is limited by the number of non-interfering coordinates. In case of GSM, it is not dependent on the area, it is dependent on only the cells or cluster. But in case of the CDMA, it is signal to noise ratio dependent. How many candidates from UP? Anybody? You have seen the चित्रकूट. एक कानपुर से चित्रकूट ट्रेन जाती है. एक सेकंड क्लास के डब्बे में 96 बैठने की जगह होती है, लेकिन उस डब्बे में 600 फीट कम माने जाते हैं. यदि 600 नीचे बैठेंगे, ऊपर बैठेंगे, सभी जगह बैठेंगे. Similar is the situation in case of CDMA. If you are ready to reduce the signal to noise ratio, you can accommodate large number of subscribers, independent subscribers. So this is the biggest advantage in case of the CDMA. So admit additional users, this is another advantage. Another advantage that the capacity is especially important is calls, आपकी call drop नहीं होगी. It will never drop call in case of the CDMA. It was possible only in GSM. So this was lecture about the cell design and improvement in the cell.